Hello everyone. In today's topic, we are going to discuss about natural logarithms. First, let us have a recall on common logarithms. A common logarithm has a base of 10. If there is no base given explicitly, it is common. You can easily find common logs of powers of 10. You can use your calculator to evaluate common logs. Now let's move on to natural logarithms. A natural logarithm has a base of e. We write natural logarithms as ln. So small letter l and n, which is we read it as ln. Okay. In other words, log x to the base e equals ln x, or the natural logarithm of x. The mathematical constant e is the unique real number such that the value of the derivative, the slope of the tangent line of the function f of x equals e to the x at the point x equals 0 is exactly 1. The function e to the x, so defined, is called the exponential function. The inverse of the exponential function is the natural logarithm or logarithm with base e. The number e is also commonly defined as the base of the natural logarithm, using an integral to define the later, as the limit of a certain sequence or as the sum of a certain series. The number e is one of the important numbers in mathematics, alongside the additive and multiplicative identities, 0 and 1, the constant pi, and the imaginary number I. E is irrational, and as such, its value cannot be given exactly as a finite or eventually repeating decimal. The numerical value of E, truncated to 20 decimal places or rounded to 20 decimal places, is 2.71828, and so on and so forth. Natural logs and E. So let us start graphing y equals e to the x. So the function y equals e to the x has an inverse called the natural logarithmic function, which is y equals ln x, or the natural logarithm of x. Y equals e to the x and y equals ln x are inverses of each other. So meaning we can use the natural log to undo the function y equals e to the x, and vice versa. All the rules still apply. It means that you can use your product, power, and quotient rules for natural logs, just like you do for common logs or regular logarithms. So suppose we have 5 ln 2 minus ln 4. It is equal to, your 5 will become your exponent, and then since it is subtraction, we are going to divide. So it is equal to ln 2 to the 5th over 4. Simplifying further, 2 to the 5th is equal to 32, and 32 divided by 4 is 8. So the final answer is ln 8. Now let us have to try this one. So 3 ln x plus ln y equals, of course, we are going to have 3 as the exponent of your x. And then, since it is plus, we are going to multiply. So, ln x to the third times y, or ln x to the third y. So, let us have some examples solving with base e. If we have 7e raised to 2x plus 2.5 equals 20. So the first thing we need to do here is to transpose 2.5. So 20 minus 2.5 is 17.5. And then we are going to divided by 7, both sides. So we have e to the x equals 2.5. From here, we are going to have ln for both sides of the equation. So the result will become 2x. So your 2x will gonna go down because we undo or we reverse the process. Okay? So 2x equals ln 2.5. Dividing both sides by 2, we will be getting ln 2.5 over 2. And using the calculator, so x is approximately equal to 0.458. So let us have another one. E raised to x plus 1 equals 30. So from here, in order for us to bring down x plus 1, we are going to apply the natural logarithm ln or ln to both sides of the equation. So applying the natural logarithm, we will be having x plus 1 equals ln 30. From here, we are going to transpose 1 to the other side. So ln 30 minus 1. Using the calculator, so just press ln 30 minus 1. So x is approximately equal to 2.401. So let us have another one. Ln x plus 4 equals 3. So from here, we are going to apply the base e so that we can remove the ln. So from here, we have x plus 4 equals e to the third. And we are going to have the value for the e to the third, which is approximately equal to 20.086. And we are going to transpose 4 to the other side. X is approximately equal to 16.086. Now let us have the last example. Ln 3x plus 5 raised to 2 equals 4. In here, we are going to apply the natural base e to both sides of the equation. So we will be getting 3x plus 5 raised to 2 or squared equals e to the fourth. And e to the fourth is approximately equal to 54.60 rounded to 2 decimal places. And from here, we are going to get the square root of both sides of the equation. And then square root of 54.6 is approximately equal to 7.39. So we will be getting the positive and the negative roots. And then we are going to solve for x. In solving for x, we are going to separate it. And we will be getting x is approximately equal to 0.797 and x is approximately equal to negative 4.130. So that's it for now. Thank you for watching and hope you learned something today. See you again next time. Bye.